480 volt, 3-phase, 600 amp type TJGE molded case circuit breaker with a microinverter trip module and ground fault tripping capability is experiencing intermittent trips. The breaker trips sporadically, sometimes with 2 months between occurrences, even with a load of 125 amps or less, and after testing confirms the breaker is in normal working order. There are 4 variable frequency drives, or VFDs, of 10 horsepower each connected to the line. A GE technician suggests harmonic buildup from the nonlinear loads of the VFD is a possible cause. Firstly, consider harmonic distortion. Harmonics from VFD can indeed cause tripping. It is recommended to install harmonic filters to mitigate this issue. Secondly, think about transient voltage surges. Surges from connected equipment or grid disturbances can trigger the trip mechanism. Using surge suppressors or transient voltage surge suppressors, also known as TVSSs, to protect the breaker is advisable. Thirdly, examine for loose connections. Poorly tightened connections can create arcing and heat buildup, potentially tripping the breaker. Make certain all connections are secure. Fourthly, look at circuit overload. Even though the breaker is rated for 600 amps, sustained loads beyond its capacity can cause overheating and tripping. Verify that the actual load does not exceed the breaker's rating. Fifthly, consider the trip module malfunctioning. The microinverter trip module could have an intermittent fault. Contact GE for further testing or replacement. Sixthly, check VFD parameter settings. Incorrect VFD settings, such as carrier frequency or modulation index, can contribute to harmonic distortion and instability. Review VFD manuals and consult with the manufacturer for optimal settings. When troubleshooting, consider these steps. 1. Monitor the load profile. Use a power analyzer to record the load current and identify any potential overloads or transients. 2. Check harmonic levels. Measure the harmonic distortion levels using a power quality analyzer. If excessive harmonics are present, implement harmonic mitigation measures. 3. Inspect connections. Thoroughly inspect all electrical connections, including those within the breaker and connected equipment. Tighten any loose terminals or wires. 4. Review VFD settings. Verify that VFD parameters are set appropriately. Consult VFD literature or the manufacturer for guidance. 5. Test the trip module. If all other troubleshooting steps fail, contact GE to test or replace the microinverter trip module. Additional considerations include breaker age and maintenance. Older breakers may experience degradation over time. Regular maintenance and testing can help identify and address potential issues. Surge protection is also something to consider. Install surge suppressors or TVSSs at strategic locations to protect the breaker and connected equipment from voltage surges. Another consideration is load balancing. Ensure that the load is evenly distributed across all 3 phases to minimize imbalances that can contribute to tripping. Harmonics are currents for voltages with frequencies that are integer multiples of the fundamental frequency, which is typically 60 Hz in the United States. VFDs, due to their switching nature, can inject harmonic currents into the electrical system. These harmonic currents can cause various problems, including overheating of equipment, voltage distortion, and nuisance tripping of circuit breakers. Harmonic filters are designed to reduce the levels of harmonic currents in the electrical system. They typically consist of tuned circuits that provide a low impedance path for specific harmonic frequencies, diverting them away from the rest of the system. Surge suppressors, or TVSSs, protect electrical equipment from voltage surges, which are brief spikes in voltage that can damage or destroy sensitive electronic components. Surges can be caused by various factors, including lightning strikes, switching of electrical loads, and faults in the power grid. Surge suppressors work by diverting the excess voltage to ground, preventing it from reaching the protected equipment. Loose connections can create resistance in the electrical circuit, leading to heat buildup. This heat can damage the insulation on wires and other components, potentially causing a short circuit or ground fault. Additionally, loose connections can cause arcing, which generates electromagnetic interference that can disrupt the operation of electronic equipment. Even if the breaker is rated for 600 amps, it's important to verify that the actual load in the circuit does not exceed this rating. The load should be calculated based on the nameplate ratings of all connected equipment, and a safety factor should be added to account for potential future increases in load. Additionally, sustained operation at or near the breaker's rated capacity can cause it to overheat and trip. The microinverter trip module is an electronic device that monitors the current flowing through the circuit breaker and trips the breaker if certain conditions are met, such as an overload, short circuit, or ground fault. If the trip module is malfunctioning, it may trip the breaker even when there is no fault in the circuit. Incorrect VFD settings can contribute to harmonic distortion and instability. For example, a high carrier frequency can increase the amount of high-frequency harmonics injected into the system. Similarly, an incorrect modulation index can cause the VFD to operate inefficiently and generate excessive harmonics. It's important to consult the VFD manual and work with the manufacturer to ensure that the VFD parameters are set appropriately for the specific application. A power analyzer is a device that can measure various electrical parameters, including voltage, current, power, and harmonic distortion. It can be used to record the load current over time and identify any potential overloads or transients. It can also be used to measure the harmonic distortion levels in the electrical system and identify the frequencies and amplitudes of the dominant harmonics. When inspecting electrical connections, it's important to look for signs of corrosion, overheating, or damage. Loose connections should be tightened to the proper torque specification. It's also important to ensure that the wires are properly sized for the current they are carrying and that the insulation is in good condition. Older breakers may experience degradation over time due to factors such as corrosion, wear and tear, and exposure to extreme temperatures. Regular maintenance and testing can help identify and address potential issues before they lead to a failure. Maintenance should include visual inspection, cleaning, and lubrication of moving parts. Testing should include insulation resistance testing, contact resistance testing, and trip testing. When installing surge suppressors or TVSSs, it's important to choose devices that are properly rated for the voltage and current levels of the electrical system. The devices should be installed as close as possible to the equipment being protected and should be properly grounded. Load balancing is the process of distributing the load evenly across all three phases of a three-phase electrical system. Unbalanced load can cause various problems, including voltage imbalances, increased current in the neutral conductor, and overheating of equipment. To balance the loads on each phase should be measured and adjusted as necessary. This can be done by rearranging the connections of the loads or by adding or removing loads on specific phases. In summary, troubleshooting intermittent tripping of a 480-volt, three-phase circuit breaker involves a systematic approach that considers potential causes such as harmonics, surges, loose connections, overload, trip module issues, and VFD settings. By following the recommended troubleshooting steps and addressing any identified issues, the problem can be resolved and the reliability of the electrical system can be improved.